Hello everybody, it's me again, Joanna. I'm your guide for Zurich meets London. Yesterday we were at the Institute for Child Health listening to a lecture Professor Dr. Klaas was given. He spoke about computational psychiatry, a very complex and for me even tongue-twisting topic, like you will see. So, hello Mr. Klaas. What does computational psychiatry mean exactly?
So computational psychiatry is a young field that, very simply speaking, tries to construct and validate mathematical models of brain function in order to understand the nature of mental diseases better, but more importantly, create new diagnostic tools that allow us to infer in an individual patient the mechanism of disease that lies hidden underneath the observable symptoms and predicts the most favorable therapeutic interventions, such as the question, which drug or which psychotherapeutic approach should we choose to treat an individual patient. The word computational has a broad meaning and can be a little bit ambiguous. So very generally speaking, computation refers to algorithmic approaches as opposed to analytical mathematical approaches. That is, we're building models through mathematical equations that really describe the step-by-step processes, both in terms of physiology, but also in algorithmic terms. In other words, what is being computed, how information processing takes place, and how these processes then give rise to measurable data, such as behavioral responses that individuals show, such as choices during a computer game, but also brain activity that we can measure non-invasively.
Thanks. And what's about the idea that the brain is a predictive model of the world?
So the brain faces a really difficult problem. It has only a few sensory channels to receive information about a potentially very complicated world. So it is in a very fundamental way disconnected from reality and only samples certain aspects of reality through a handful of sensory channels, such as vision, audition, touch, taste, etc. Now, those inputs are highly ambiguous, and the brain has to make sense of them, has to interpret them, and has to infer upon the true state of the world that has given rise to these inputs. And it can only solve these problems by means of a model that it has about the world that generates predictions about what in the world most likely caused those sensory inputs, and then update that model based on experience and based on prediction errors.